Hi, everyone, and welcome to the Machine Learning Interview Hub. Today, we're going to talk about the system design on recommendation systems, specifically about Ads Fetcher or Ads Finder. Have you ever wondered how platforms decide which ads you see in less than a second? Behind the scenes, there is a highly optimized machine learning system that filters hundreds of ads down to just a few, all in real time. In this video, we are breaking down an ad finder system and explaining how multi-stage ranking works in production. Let's start with the big picture. This system works like a funnel. We begin with a large pool of ads and progressively narrow it down through multiple stages: retrieval, filtering, ranking, and auction. In this example, we go from 350 ads to just two final ads, all within about 575 milliseconds. Now let's go step by step. The first stage is candidate retrieval. This is handled by a component called Ad Indexer Fetcher. Here, the system retrieves around 350 ads using simple techniques like keyword matching, user targeting, and basic relevance signals. This stage is optimized for recall, not precision. The goal is to make sure we do not miss any potentially relevant ads. Next comes the trimming stage. Here, we reduce the number of ads from 350 down to 269. We remove ads that are clearly not eligible, such as campaigns that have run out of budget, ads that violate policies, or ads that do not match the user's targeting criteria. This step is fast and mostly rule-based. Think of it as removing obvious noise. After that, we move into the first ranking stage, often called pre-ranking. At this point, we go from 269 ads down to 221. This stage uses lightweight machine learning models, such as logistic regression or simple scoring functions. We estimate signals like click-through rate and basic relevance. It is still fast, but more intelligent than simple filtering. Now comes the most important part, the second stage ranking. Here we take 221 ads and run them through more advanced machine learning models, reducing them to 153. These models use rich features like user behavior history, context such as time and device, ad attributes, and complex feature interactions. This stage is more computationally expensive, but also much more accurate. That is why we only apply it after we have already reduced the candidate set. Next is the truncation step. After ranking, we aggressively cut down the list from 153 ads to just 37. We keep only the top scoring ads. In some systems, this step also enforces diversity or fairness constraints to avoid showing too many similar ads. Finally, we move to the auction and delivery stage. Out of the 37 ads, only 2 are selected and shown to the user. This is done using an auction mechanism, where each ad has a bid and a quality score. The system combines these signals to decide which ads win and in what order. The goal here is to balance relevance for the user with revenue for the platform. In some cases, there is also a post-processing step. This can include calibrating scores, applying business rules, enforcing frequency caps, or making final adjustments before showing the ads. All of this happens within a strict latency budget of around 575 milliseconds. Early stages are designed to be fast and lightweight, while later stages are more accurate but applied to fewer candidates. This is the core idea behind multi-stage ranking. You use cheap operations early to reduce the problem size, and expensive models later to maximize quality. To summarize, this system starts with broad candidate retrieval, progressively filters and ranks ads, and ends with an auction that selects the final winners. This combination of machine learning and economic optimization is what powers modern ad recommendation systems. If you found this helpful and want more deep dives into machine learning system design, make sure to subscribe to MLE Hub.